Back to Mr. Hassan's Maths channel. I'm now answering a question from one of the Solomon collection of M1, Mechanics 1, from the Edexcel old questions. And this question here is about moments. And it's question number 1 from my end of topic worksheet on moments from my Edexcel collection. And it's also question number 3 from this particular Solomon paper. And we have this figure 1 which shows a uniform plank AB. Okay, sorry, uniform plank AB of length 8 meters and mass 30 kilograms. It is supported in a horizontal position by 2 pivots, one situated at A and the other 2 meters from B. Okay, this one here, let's just call this pivot C. All right, we'll just call it C. Now, a man whose mass is 80 kilograms is standing on the plank 2 meters from A, and when his dog steps onto the plank at B, okay, when his dog steps onto the plank at B, so the man is standing at A, and his dog is standing at B at the end of the plank. Given that the plank remains in equilibrium, and that the magnitude of the forces exerted by each of the pivots on the plank are equal, calculate the magnitude of the force exerted on the plank by the pivot at A. Okay, so now they've told us a few things here. They've told us that it's a uniform plank, right? So, of course, it has a weight, but the fact that it's uniform means that the weight is evenly distributed along the length of the plank. Therefore, we can take its weight as acting through its geometric center. What does that mean? Well, it means that the weight acts exactly halfway along its length. So if this is 8 meters long, then exactly 4 meters in from either end will be where the weight of the plank is going to be acting. And we know the mass is 30 kilograms, so the weight is 30 times g, which is acceleration due to gravity. Weight equals mg, so 30 kilograms, or 30 newtons, sorry, is the weight of this plank. Okay, so that's acting exactly in its geometric center, which is, you could say, 4 meters in from A. 4 meters in from A. That distance is 4 meters because it's halfway along the plank. That's where the weight's at. So that's one thing we can mark on here. And we know that it told us that the plank remains in equilibrium and that the magnitude of the forces exerted by each of the pivots are equal. So you have 2 forces acting at A and at B, which are equal, which are the forces acting on the plank by the pivot. Okay, we're looking at the forces acting on the plank here, right? So those 2 forces, the reaction force of the pivot at A and also at what we've called C. Okay, I don't know if we need to even call it that, but I've just called it C, right? These 2 reaction forces, which are called R, they're both equal to each other. The reaction at A and the reaction at C are equal, as they told us. Okay, the reaction at A and C are equal. So they're both, we just call them R. Okay, so they're both equal, so we can call them the same letter. Now, so those are acting vertically upwards, right? Perpendicular to the surface. What else do we know? The man has a mass of 80 kilograms, so his weight is going to be 80 g, acting straight down. That's 80 g newtons. All right, and we don't know the mass of his dog, so we can't find the weight of. We don't know the weight of the dog, so we know that it has a mass. I'm going to call it M. Let's call it MD, mass of the dog. So this is the mass of the dog, which we don't know. Right. So we want to find the reaction force of A. We want to find the reaction force at A, which is going to be the same as the reaction force at C. Now, for us to do this, we know that's in equilibrium, meaning that all the forces are balanced out. And also it means that all the moments, okay, the clockwise moments and the anti-clockwise moments are equal. Okay. because it's an equilibrium, the clockwise moments and the anti-clockwise moments that we take from any point we want to will be the same. They cancel each other out because it's an equilibrium. So we can take moments about any point we want to. Now, I can't find the value of R by equating the upward forces and the downward forces, because there's one of the downward forces we don't know. It's unknown. We'll have two unknowns, R and the mass of the dog, right? And if I take moments about anywhere, I'll have two unknowns. I'll have R and the mass of the dog unknowns, unless I decide to take moments about B. If I take moments about B, then the only thing that's unknown, because if you take moments about B, then the turning force about B will be 0, because the distance of the mass, the force from B is 0, right? The distance of the turning factor is the distance of the force from that point times the magnitude of that force. So the turning effect of this force about B will be 0, and the only thing we won't know is what R is, because these two R's are the same. That will be the only unknown in our equation. So the sensible thing here is to take moments about B. Take moments about B. All right, so I'm going to take moments about B, so that's my pivot. All right, so I've got to think, what are the clockwise moments and what are the anti-clockwise moments? So of course, if we take moments about B, the clockwise moments will be the ones that are acting cause that type of movement, if that was a pivot. Okay, so now we can see that we've got this distance here, which is 2 times R plus, and then we got this distance here, which is 8 times R. Okay, those are the clockwise moments. And they must be the same as the anti-clockwise moments will be caused by these two forces here. Of course, this is going to be 0. So you're going to have 30G times 4. 30G times 4 plus, and then you're going to have 80G, which is the weight of the man. And how far is he away? He is basically this distance away from B, which is 6 meters, 4 plus 2. So he's going to be 6 meters away from B, so that's 80G times 6. So you see, the only thing we don't know is R now. So you're going to have 10R is equal to, that's 4 times 3, that's 120 times G, plus 6 8s are 48, so 480 times G. So we can say 10R is equal to, that's 600 G, 480 plus 120. So R is going to be 60 G newtons. R is going to be 60 G newtons. Okay, so in terms of Edexcel, we're going to use 9.8. So it's 60 times 9.8, which gives us 588 newtons. 588 newtons. Now, if you left it in terms of G, that would be fine. If you wrote 3SF, that would be fine. We could even write it in 2SF because we used G here. So we could even write this as 590 newtons if you wanted to, and that would be fine. All of those three would be acceptable. All in Edexcel, where you use G as 9.8, you can write it to 3SF or 2SF, or even leave it in terms of G. They would accept that, right? Unless they told you something else in the question. So there's part A done. So for us to be able to answer this question with two unknowns, we have to take moments about the one of the unknowns. We're trying to find what R is. Okay, the reaction force, of course, it's best for us to take moments about this, which is unknown. Okay, if I take moments about C, for example, I'd have an R in my equation, but I'll also have a mass that I don't know. I'll have two unknowns, and I won't be able to solve it. Okay, so the easiest way is for you to take moments about the thing which you want to eliminate from the equation, and that will leave you with one unknown. Okay, we could take moments about C and then take moments about A and have two equations with two unknowns, and then we can solve it, but it's a lot more hassle. All right, now part B says find the dog's mass. Okay, so now we know the reaction forces. We can use the fact that the upward forces and the downward forces are the same. Or if you want to, we could take moments about any point we want, and do it. So for example, I could take moments, now I know what R is, I can take moments, for example, about C, or even the center here. I can take moments about the center, and the clockwise moments and the anti-clockwise will be equal. But I think the easiest thing to do is to use the fact that we can say that, we have R plus R. So there's 2R is equal to 80G plus 30G plus the mass of the dog times G. I should put mg there. The mass of the dog times G. Right? So find the dog's mass. So the upward forces and the downward forces are equal to each other. So you have the two reactions, and you have the weight of the man, and you have the weight of the plank, and you have the weight of the dog. Right? Those are the downward forces. Okay? And some people do ask, actually, oh, how about the reaction force of, the plank on the man? No, we're considering the forces that are acting on the plank. The force exerted on the plank. So the force exerted on the plank by the pivot is R. The force exerted on the plank by this pivot is R. The force exerted by the weight of the plank is 30G. Okay, that's the weight acting on the plank. The force of the reaction force, or you say the weight of the man, it's basically, you can think of this as a reaction force of the man on the plank. You can think of it like that, right? And same with this for the dog. That's how you can think of the weights in this case. Now, so there is a reaction force on the man from the plank, but we're not considering that. We're considering the forces acting on the plank alone. Okay, so that's also a common question. Why didn't you draw the reaction force? We're not considering reaction force, the forces on the man. We're considering the forces on the plank. That reaction is a reaction force on the plank. This is the reaction force on the plank as well, and as is this. Okay, so we have 2R, and we know the value of R. So we have 2 times 60G is equal to, that's 110G plus mg. You notice the g's cancel out. That's why it's good to put things in terms of g. And you end up with 120 minus 110 equals m. So m is equal to 10 kilograms. That's the mass of the dog. Okay, so there's your answer to part B. And then it says part C, if the dog was heavier and the plank was on the point of tilting, explain how the force exerted on the plank by each of the pivots would change. So if it was on the point of tilting, then the reaction force at A, so you can say that the reaction force on A would equal 0. Okay? And the reaction force at B would be equal to, okay, all of the, combined weights of everything. So RB would be increased. It will be increased, and it will be equal to the total weight of everything else. So it will be equal to 80G plus 30G plus 10G. It will be the total weight of everything on the bottom. All of the reaction force on C would be everything. Okay, because if it's on the point of tilting, what's going to happen is this is going to lift up from here. When it says it's on the point of tilting about, okay, it will be on the point of tilting about C. If this dog was heavier, what's going to happen is it's going to tilt like this. It's going to lift up from A because it will tilt about C. If this was heavy enough for it to start tilting, then it's going to go like this. Right? It will lift up like that. So if it's on the point of tilting, it means that's just about to happen, in which case the reaction at A will be 0, and all the reaction will be on C alone. So it will take all those weights. Okay? So you can say the reaction at A will become 0, the reaction B will be increased, and it will equal, you see, all of this. It's going to be 120G will be on the reaction of B alone. Okay? So, yeah, I guess that's enough. That question. So that answers question number 3 from the end of the topic worksheet, and question number 1 from this. Question number 1 from the end of the topic worksheet, and question number 3 from Solomon A papers. Other questions from the Solomon A M1 papers can be found in the playlist that will appear in this region here. Other questions from this end of topic worksheet or moments from my Edexcel collection can be found in this playlist. Questions from moments in general from Edexcel can be found in this playlist over here. And you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.